Hello, this is Derek, and this is section 9.2, solving quadratics by factoring. Not a terrible section. We've already done the factoring a couple of chapters back, so this just kind of has one additional step. And what that additional step is going to be applying the zero product property. And so what this is saying if I have something in the form a times b, or just two things basically, multiplying equals zero, one or the other or both have to be zero. So our steps for solving by factoring is first to get the equation set to zero, factor it completely, and then the zero product property is where we set the factors to zero and solve. These first couple are already factored for us, and it's just to kind of show this piece of it, and then the rest of the homework will be actually factor and solve. And this method for solving is great. This is kind of your first, if this is the first thing I would try if I had a quadratic. First thing I'd look is, does it factor? And if so, this is usually going to be the easiest method. It doesn't always factor, so then we have some other methods like what we saw in the last section, and then what's coming up with quadratic formula. So zero product property, already factored, so it's set to zero, it's factored. So now we're just going to set each of these factors to zero and solve. First, I'm going to set this 8 to 0 just to show 8 does not equal 0. There is no x in this term, there's nothing to solve. When we get over to this one where there's a variable there with the 2, that's going to do something, but when we just have a number, the number doesn't equal 0, so we're all good. This next one, we'd have x minus 3 equals 0. So then solving, I would do just like I would do, right? I'd add this 3 over, and we got x equals 3. And you can see if I put 3 in here, 3 minus 3 would be 0. 0 times who cares would make 0. And likewise, x plus 6 equals 0. So here I minus the 6. And x equals negative 6. So likewise, if I put negative 6 in, negative 6 plus 6 would be 0. And then 0 times who cares what those came out, it's still 0. So these are my zeros, or my solutions to this equation. If you notice, so up here we have the factors. So these are called the factors, and these are called the zeros. The factors and the zeros are going to have opposite signs, and that's because that step in red. So there's no reason to show this every time. You can just look at these, right, and go, okay, so if I have x minus 3 as a factor, 3's got to be a 0. X plus 6 is a factor, so negative 6 has to be a 0. This next one is the same thing. It just looks a little bit more complicated, but let me show you that. So this 2y in front, I talked about that one earlier. So if I have 2y equals 0, that is solvable. Y could just be 0, right? Because if y was 0, 2 times 0 would make 0. So this time we have 1, 2, 3 y's, so we're going to get 3 answers. So with that variable there, that's the difference between these two. So there's our first solution. And then we have 3y minus 1 equals 0. If you can see the answer is 1/3, great, just write it down. If not, I'm going to add this 1 over and get 3y equals 1, and then I'll divide the 3 on both sides. And so there's the y equals 1/3, and then do the exact same thing with the third factor. 2y plus 5 equals 0, subtract 5 on both sides. 2y equals negative 5, and then divide out the 2, and y equals negative 5 halves. So basically that's the new math in this section. That's the part we hadn't seen. Everything else is stuff we have done before. Okay, so this first one is solve if possible, answer D and E if there are no real solutions, and sometimes there are not real solutions. This one's a 4-parter because these are a bunch of equations that often kind of get mixed up with one another. So this first one is x squared minus 81, so that's our difference of squares. So that would factor to x plus 9, x minus 9 equals 0, and we get x equals negative 9 or x equals positive 9. So that's our basic difference of squares. We could have also solved this the way that we did in the last section. We bring the 81 over and root both sides. X equals plus or minus 9. So same two solutions, two ways of getting there. This next one, people make this harder than it is. It's x squared plus 9x, so that just has a common factor of x. And so x plus 9 is what would be left behind. So this first one, that's where x equals 0. Anytime we have a coefficient out front with a variable, that's going to be a 0. And then the second 0 is at negative 9. C, this is what multiplies to be 81 and adds to be negative 18. So you could write that x minus 9, or you could write it x minus 9 squared, either way. But there's this one only has 1 0. This is going to be x equals positive 9, and that's it. And then this one does not have zeros. And so the reason this doesn't have zeros is because if I try to solve it, 81, or x squared equals, bringing that 81 over, negative 81, you can see when I do the root, I'm getting the root of a negative, so that has no real solutions. So that is a D and E. The geometry that we're going to see with these three coming up when we do the graphing, very briefly, for this first one, what we found was a parabola that looks like this, and it has zeros on negative 9 and 9. For the second one, we had a parabola that's coming down and it's bouncing off of 9, and that's why we only have one solution. For this third one, we have a parabola that's up here and opening up, and so it never crosses the x-axis, so that one has no solutions. So that's kind of the geometry behind why we have these three different outcomes. And then these remaining problems are just solve. So our first step is to get it equal to 0, so we subtract that 22 on both sides, and rewrite this as x squared plus 9x minus 22 equals 0. And then I'm just looking for two numbers that multiply to be negative 22 and add to be 9. And so that will be x plus 11 and x minus 2. So from there, x equals negative 11 and x equals 2. For that next one, we're going to distribute the x through. I can't solve this as is because it doesn't equal 0. It's sort of, I mean, this side is sort of factored for what it is, but it's not set to 0, so that doesn't do me any good because I need something times something equals 0. So I gotta go x times 5 and get a 5x. X times negative x for negative x squared equals 6. So I find it much harder to factor with a negative term here. So what I'm gonna do is I'm gonna bring these over this way so that I get a positive squared term. So I'm going to go minus 5x plus x squared minus 5x. So those cancel, giving me 0 on this side. And then descending order, I'd have x squared minus 5x and then plus 6. So from there, I need two things that multiply to be 6 and add to be negative 5. So that sounds like x minus 2 and x minus 3. So solutions are 2 and 3. Okay, and then this last one, again, doesn't equal 0, so I have to do some work there. So I'm going to go r times r is r squared. On the outside, I get minus 3r. On the inside, I get plus 2r. And at the end, I get minus 6 equals negative 6r. So this time I'll bring stuff this way because the squared is positive. And before I do that, let me collect terms, just because it's a good habit. So now, oops, let me not drop the sign. So we'll add the 6r over, and we get r squared plus 5r minus 6 equals 0. So this one's a minus 6, so you gotta be a little careful with those signs. That's gonna go r plus 6 and r minus 1. So multiplies to negative 6, adds to be positive 5. So our solutions are negative 6 and positive 1.